Good morning, everyone, and a happy morning to all the students. So it's a time for chemistry webinar. Myself, Mrs. Sridevi Polu, Principal, TSMS Pudu, is privileged to be here and to introduce the speaker of the day, Mr. Jahangir Garu, PGT Chemistry from TSMS Bandwaram, Vikarabad district. And dear children, see, let me introduce Mr. Jahangir Garu to you. So prior to our model schools, before 2013, Sir worked in eminent educational institutions and where Sir has given training for the JEE mains. And dear children, Sir is a very hardworking teacher and he is an eminent chemistry faculty. And it's my pleasure to introduce Mr. Jahangir Sir to you all. Good morning, Jahangir Sir.
Good morning, madam.
Good morning, sir. Please welcome to the chemistry webinar. And dear children, in our previous sessions, we have learned about atomic structure, periodic classification of elements, chemical bonding, and today it's the time for states of matter. And in the states of matter, you are going to learn about the gaseous state and also about the liquid state. And what are all the gas laws? Boyle's law, Charles' law, Graham's law of diffusion, Avogadro's law, about all the gas laws you are going to learn. And what is the states of matter? In how many states does the matter exist? About all these things, Sir is going to teach very interestingly to you all. And let me hand over the session to Jahangir, sir. So please welcome, sir.
Thank you, madam. Thank you for a fabulous introduction.
Thank you. Thank you so much.
Respected Good afternoon, respected principals and teachers. Thank you for giving me opportunity to participate in this webinar session. Thank you, one and all. So, good afternoon, children. How are you? First of all, introduce myself. Myself, Mohammad Jahangir, working as a PGT Chemistry, Bantwara Mandal, Vikarabad District, Telangana Model School. So, once again, good afternoon, students. All of you safe at home, and stay safe, but never stop learning because time and tide waits for none. Okay. So today I am going to start a new lesson, intermediate first year chemistry, gaseous state, nothing but states of matter, liquids and gases. So first of all, states of matter, gases and liquids. So before entering of this detailed discussion of the chapter, once we see the chapter overview, so the subtopics are present in this states of matter, gases and liquids are, first one is intermolecular forces, and next gas laws, ideal gas equation, Graham's law of diffusion, Dalton's law of partial pressure. Next, kinetic molecular theory of gases, kinetic gas equation of an ideal gas, deduction of gas laws from kinetic gas equation, distribution of molecular speeds like RMS, average and most probable speeds. Next, kinetic energy of gas molecules, behavior of real gases, deviation from ideal gas behavior, compressibility factor versus pressure diagram of real gases. Next, liquefaction of gases. Next, come to liquid state, another state of matter, and I will discuss about the properties in terms of intermolecular attractions. In that, some of the properties we'll discuss: vapor pressure, surface tension, and viscosity. So these are the subtopics are present in the states of matter, gases, and liquids. So now come to in today's session, we are going to discuss these topics. So let us discuss the session overview of this chapter. Session overview of this topics. First one is types of molecular forces. Today's session overview topics, childrens. Are you listening? So types of molecular forces. Under types of molecular forces, dipole-dipole interactions and dipole-induced dipole interactions and dispersion forces are also called London forces. And next, ion dipole interactions and hydrogen bonding, intermolecular forces versus thermal energy, gaseous state and their physical properties, gas laws, under gas laws, Boyle's law and Charles' law. And some numerical problems also we will discuss based on the gas laws. Okay. So now come to actually enter into the chapter. So before entering into the chapter, so I will ask you one definition, students. You know very well because you learned in your previous classes. What do you mean by matter? What do you mean by matter? Matter means what? Children, tell me what is mean by matter? Yeah, right, correct. So matter is nothing but anything which occupies the space and has matter. Defined. What is the matter, student? Matter is defined as anything which occupies and has mass is called as what? Matter. So everything in this world, everything is comes under of matter only. What are the examples? So many examples you can take. So example like water, pen, air, and soil, oxygen, carbon dioxide, petrol, kerosene, diesel, so many, everything. Our earth is only a one matter, means everything, whatever the materials or substances are present on the earth, also everything comes under of matter only. So that is the basic definition of matter. So next one is usually these matter is exist in three physical states, normal conditions. One is called the matter. One is called as plasma state and other one is called as Bose-Einstein condensate state. But we will not discuss detail about those states of matter, plasma state and other one is Bose-Einstein condensate state. So why? Because they are exist under abnormal conditions, means very low temperatures and at very high temperature only they are possible. So under normal conditions, the existence of matter is mainly three types: liquid state and come to the gaseous states. So any physical states of matter is exist depends upon its temperature and pressure. So here highlighted the word, children. What is that highlighted word? Temperature and pressure. These two terms are very important in the present of matter. So here one pictorial representation of given about the three physical states of matter, children. Solid state, arrangement of particles in solid states. In solid state, the particles, whatever the particles may be, ions or atoms or molecules, they are tightly and closely packed. And come to the liquid states, a little bit far away from each other comparatively solid state. This is about arrangement of particles of solids, liquids, and come to the gases. And next one is come to the shapes. You know very well about the shapes of solids are fixed, and come to the states of liquids are unfixed, and gases also what are unfixed. And next movement, usually in solid state, the particles are tightly and closely packed. The molecular forces of attractions are very strong. Hence why they cannot move easily. Just they can vibrate from their mean positions. And come to the liquid states, move around each other. And come to the gaseous state, they are freely and quickly moves in all directions without any particular directions. Come to the energy of solids very low, and come to the liquids medium, and gases are very high. Why? Because just why solids energies are low? Because they vibrate from their mean position only, hence their energies are becomes very low, and gases are very high. Okay, so this is the basic physical states of matter. So any physical states of matter, that is whether the solid state, liquid states, their chemical properties are same only the difference on the rates of chemical reactions. Nothing but speeds of reactions are changes. Properties are same. Means if you take ice or water vapor, the formula is same. H2O only. In ice also H2O, water also H2O, gases vapor also H2O only. The difference is what? Just the physical state, the force of attractions are different. Next student. So just now we discussed the existence of present physical states of matter is depends upon the temperature and pressure. So by changing of temperature and pressure, one physical states of matter can be converted into the another physical state. One physical state of matter can be converted into the another physical state. So this phenomena is known as solids are converted into the liquids. That phenomena is known as fusion or melting. Vice versa, liquids are converted into the solids. That phenomena is known as freezing. Similarly, liquid to gas. If you take liquid to gas also, conversion of liquid state of matter to gas is called as evaporation, and vice versa it is called as condensation. And gases also can be converted to solids, and solids also can be converted into the gases. This phenomena is known. Conversion of gas into solid is called as sublimation, and conversion of solid to gas is known as what? Gas to solid is known as a solid. Important example, solids are converted into the liquids takes place by absorption of heat, and solids by evolution of heat in liquid to gases and gases to liquid.
Hello children. Just 1 minute, sir will join and continue the session. And today you are learning about the gaseous state, isn't it? That is the states of matter. Matter exists in 3 states: solids, liquids, and gases, isn't it? Then how this difference has arisen? And this difference is due to the arrangement of particles. We all know that in solids, the particles are compactly or closely arranged, whereas in liquids, they are loosely packed. Whereas in gases, they are far away from each other. Jahangir sir, please continue, sir.
Madam.
Okay, sir. Please start sharing the screen, sir.
Yes, start. So like one physical state can be converted into the another physical states. It depends on temperature and pressure. Okay. So the next one too. So whether any physical states of matter, either it is a solid state of matter or in a liquid state of matter, solid state or liquid state of matter. So in between the solid or liquid state or gaseous state of matter, the molecular forces are present. Molecular processes are present. So due to the presence of molecular forces, they are becomes stable. They are becomes what? Stable. So these molecular forces are categorized into the two types, students. So what are the two types of molecular forces? Molecular forces are nothing but the force of attractions. Force of attractions between the molecules are known as molecular forces. These molecular forces are categorized into the two types. The first one is intramolecular forces, nothing but bonding forces. And the second one is intermolecular forces, means non-bonding forces. Like
Dear children, see, we were learning about the states of matter, isn't it? Matter exists in 3 states: solids, liquids, and gases. In solids, the molecules are very compactly or closely arranged, and then in the liquids, they are loosely arranged. And whereas in gases, they are far away from each other. And in this session, you are going to learn about the intermolecular forces. What are these intermolecular forces? Right? See, we can see that they are the attractive forces or the repulsive forces which exist between the molecules, right? And then we are going to learn about the gas laws. In your previous classes, that is in your lower classes also, you have learnt about the gas laws. Boyle's law, Charles' law, isn't it? See, what is Boyle's law? See, Boyle's law states that for a given mass of a gas, what is it? For a given mass of a gas. So the pressure is inversely proportional to the volume, keeping the temperature constant. So at constant temperature, the pressure of a gas is inversely proportional to its volume. So it is called as Boyle's law. And what is Charles' law? For a given mass of a gas, at constant pressure, the volume is directly proportional to the absolute temperature. So that is called as Charles' law, isn't it? So today we are going to learn about these gas laws, children. So due to some technical issues, sir has left the class. Again, he has joined. Okay. So please continue.
so two types of molecular forces. So first one is intramolecular forces and other one is intermolecular forces. So what is the difference between the intramolecular forces and intermolecular forces? So intramolecular means the force of attractions which exist within the molecule is known as intramolecular forces. So examples, intramolecular forces, ionic bonds and covalent bonds are the examples of intramolecular forces. Children, you have already learned the chemical bonding and molecular structure in the third lesson. In that detailedly explained about, madam, about ionic bond and covalent bonds, formation of ionic bond and covalent bonds. So next one is intermolecular. This is a force of attraction between molecules is known as intermolecular forces. Examples: air is a mixture of several gases. In that gases, so many gases are present, like oxygen gas and nitrogen gas and carbon dioxide gas, and so many gases are present. In between those gases also, molecular force of attractions are present. Such forces are known as what? Intermolecular forces. Some of the examples of electron forces and ion dipole forces are examples of intermolecular forces. Children, molecular forces are two types: intramolecular forces and intermolecular forces. Intramolecular and intermolecular. Intra means within, inter means in between. Intra means what? Within. Inter means what? In between the molecular forces. So like molecular forces are two types: intra and intermolecular forces. Okay. Then next come to, again, these anyway, intramolecular forces are detailedly studied in the chemical bonding chapter. Chemical bonding chapters. Ionic bond, covalent bond, and coordinate covalent bond, and remaining all are learned in the chemical bonding and molecular structure chapter. So here we are going to discuss about intermolecular forces and what are the types, how many types of intermolecular forces are there, that we will discuss here. Okay. So under the types of intermolecular forces, first one is a dipole-dipole forces, and second one is dipole-induced dipole forces, and third one is dispersion forces, and fourth one is ion dipole interactions, and fifth one is hydrogen bonding. So among these five types of intermolecular forces, the first three forces are known as van der Waals forces. Van der Waals forces. Van der Waals forces are nothing but the weakest molecular forces of attractions in between the molecules are known as van der Waals forces. Among these five type of intermolecular forces, the first three forces are very weakest forces. This was first invented by van der Waals, scientist name on the honor of van der Waals. The first three forces, dipole-dipole forces and dipole-induced dipole forces and dispersion forces, are collectively called as van der Waals forces. So, and anyway, ion dipole interactions and hydrogen bonding also comes under of intermolecular forces only, but these are little bit stronger than the first three forces. So in between intermolecular forces and intermolecular forces and intermolecular forces, intramolecular forces are stabilizes the individual molecules. Intramolecular forces are stabilizes the individual molecule, and intermolecular forces are explain the bulky properties such as like melting points, boiling points. Okay, these are all explained based on intermolecular forces. Now come to the one by one discussion of intermolecular forces. The first come to the first type of intermolecular forces are dipole-dipole forces. Dipole-dipole forces. Children, students, what do you mean by dipole? So di means, the pronunciation of the word di means two. Pole means what? In chemistry, the poles are nothing but here positive and negative charges. Partially positive and negative charges, like dipole. So force attractions between the force of attraction between the two dipole molecules are known as, the force of attraction in between the two dipole molecules are known as dipole-dipole forces. Here clearly one picture is given about the dipole-dipole forces, formation of dipole-dipole forces in between HCl molecule, hydrochloric acid, HCl and HCl. So why these dipoles are developed means because of unequal shade pair of electrons are present between the hydrogen and chlorine. Unequal electron pairs are present in between the hydrogen and chlorine. Actually here covalent bond is present. Covalent bond is nothing but shade pair of electrons. Usually two electrons pairs are present in single bond. So in this single bond, two electrons are, these dots are represents what? Electrons. These are very close to chlorine. Why? Because chlorine is more electronegativity nature. because of it possesses partial negative charge, and because of by partial loss of electron it possesses partial positive charge. Hence why they possess negative charge due to attraction of electron. They possess negative charge due to the loss of electrons, partial, not completely. So they possess partial positive charge. Okay, so like that the dipoles are developed within the molecules. So here one dipole molecule, if another dipole molecule, two dipole molecules are present here. So whenever these dipole molecules are lie along the axis in between the partially negative charge dipole and partially positive charge dipole, a tiny electric field is developed, attractive force is developed. Such attraction is nothing but dipole dipole forces. Dipole dipole forces, children. So this is about the dipole dipole forces, children. Here next one is so come to the dipole dipole forces are attractions which acts between the polar molecules. First point, dipole dipole are force of attractions which acts between the polar molecule. So usually when polar molecules are lie nearer one charge, act as a tiny electric fields that orient them and gives to a dipole dipole forces. Children, clear? So like this dipole dipole attractions are develops. Next one is some common examples we can see in the formation of dipole dipole forces are sulfur dioxide, nitrogen dioxide, HCl are some examples of dipole dipole forces. Okay, so in this dipole dipole forces, the interaction energy between the molecule is directly proportional to the 1 upon r power 6. 1 upon r power 6. Here r is nothing but distance between the two molecules. So here 1 upon r power 6. It is applicable to the rotating polar molecules. So rotating polar molecules are nothing but like a liquids. And in the dipole dipole forces, interaction energy is directly proportional to 1 upon r power 3 or r cube. This is in case of stationary polar molecules, means like in solids. Okay, so that is about dipole dipole forces. So like in between the molecules also one kind of force are present, that is dipole dipole forces. First type of forces. And the next one is second type of forces are dipole induced dipole interactions. Dipole induced dipole interactions. Usually these dipole induced dipole interactions are exist in between a polar molecule having permanent dipole nature to the non-polar molecules. You know students very well about the polar and non-polar molecule. Polar molecules means in between the two atoms electrons are unequally distributed. They are called as polar molecules. Previous example I clearly explained you, hydrogen chloride, HCl. In between the HCl, you can see electrons are unequally shared. Electrons are unequally shared. Polar molecule the non-polar molecules close to each other.
Dear children, stay online. Sir will continue the session. Just few technical issues. I hope you will understand. I think everyone is writing down the notes, children. See, we are very happy as we are reaching you every day with our webinars. And it's our privilege to be a part of this, children. Hope everyone is writing down the notes and learning the lessons properly. See, the intermediate board has announced the schedule for your examinations and all. So keeping in view about all these things, you have to attend these webinars and write down the notes, children. So in our previous sessions, we have learned about atomic structure, isn't it? Structure of atom. See, from that, you just learn the postulates of Bohr's atomic model and then how it explained the hydrogen spectrum. That is a formation of spectral lines in the hydrogen spectrum. And also in your second lesson, that is the periodic classification of elements, you just learn the salient features of long form of periodic table and then division of elements into blocks. Okay? Okay. Sir, please continue, sir.
Okay. So here dipole-induced dipole interactions are existed. The interaction between a polar molecule and dipole-induced
Children, please try to learn the 8 marks questions from the previous sessions which you have learned. That is from atomic structure, you had to learn about the Bohr's theory postulates and also the spectral lines in hydrogen spectrum and quantum numbers, right? And explain Max Planck's quantum theory. And from your second lesson, that is periodic classification of elements, you just try to learn about the salient features of long form of periodic table, division of elements into blocks, S block, P block, D block, and F block. See, they are very simple to write, children. See, don't get confused. And then you just learn the division of elements according to their chemical properties. Inert gases, representative elements, transition elements, and inner transition elements. And then about the periodic properties. In our previous sessions also, we have discussed how these periodic properties vary in a group and in a period. Atomic radius, ionization enthalpy, electron affinity, electronegativity, oxidation states, metallic properties, isn't it? Then about atomic radius. See, if you learn about atomic radius, every periodic property is linked with its atomic radius, isn't it? What is atomic radius? The distance between the nucleus and the valency shell electron is called as atomic radius. What happens to the atomic radius in a group? In a group, the principal quantum number increases enormously. Enormously means it increases in a large scale, isn't it? Right? So when it increases from top to bottom, the atomic radius also increases because the number of principal quantum levels also increases. And in a period, the atomic number increases only by 1 unit from one atom to another atom. And here, the valency shell electrons enter into the same principal quantum number and also into the same orbital, right? So, by this, what happens? The atomic radius decreases. So, every periodic property is linked with the atomic radius. You check out once. Okay, so then coming to the next thing, that is ionization, enthalpy. Enthalpy or energy. Ionization, the process of removal of electrons, isn't it? The minimum amount of energy required to remove the most loosely held electron from the outermost orbit of an isolated gaseous neutral atom is called as ionization enthalpy. See what happens to the ionization enthalpy in a group. In a group, ionization enthalpy decreases. See why it decreases? Because of increase in atomic radius, isn't it? See, just I'm briefing out all the important 8 marks questions, what you had to learn in your previous sessions who had children. Then coming to the next one, that is chemical bonding. In chemical bonding, we just try to learn about hybridization, the mixing of pure atomic orbitals to form new hybrid orbitals. And then the orbitals which have equal energy, right? Which are degenerate, we can call them, isn't it? See, they combine and form new hybrid orbitals. So this is called as hybridization. Then how many types of hybridization is there? And then what are the examples you have to learn? So this is the question which is very frequently asked from your chemical bonding. And then coming to the molecular orbital energy theory, right? That is a molecular orbital energy diagram also. So you have to learn the postulates of this theory and how to draw the diagram for different homoatomic molecules, right? So for nitrogen, oxygen, fluorine and all. And in this chapter, that is gaseous state, what you are learning right now. In gaseous state, you have to learn about the gas laws and how these gas laws are deduced from the kinetic gas theory. Okay, so please try to learn these questions from your previous sessions and also from today's session, children. Sir will join soon. Okay, so please cooperate with us. Don't leave the class. I hope everyone is writing down the notes, children. So please feel comfortable and thank you for supporting us, right? So let me explain you about the another property, periodic property, that is electronegativity. What is electronegativity? See, it is a tendency to attract a shared pair of electrons towards itself in a covalent molecule. Is called as electronegativity. What happens to the electronegativity in a group? In a group, electronegativity decreases. Why it decreases? Again, atomic radius comes into the picture. So as the atomic size increases from top to bottom, the electronegativity decreases. And in a period, what happens? Let us see. In a period, the atomic number increases only by 1 unit from one atom to another atom, isn't it? So as the atomic number increases by only 1 unit and the electrons enter into the same principal quantum level. So what happens to the electronegativity? It increases. So as the atomic radius decreases, the electronegativity increases. And then coming to the next one, electron affinity. The amount of energy liberated when an atom accepts an electron and becomes an anion is called as electron affinity, right? So what happens to this? Again, atomic radius comes into the picture. So from top to bottom, atomic radius increases. Then what happens to the electron affinity? It decreases. And in a period, as the atomic radius decreases, electron affinity increases. And you have to remember about the important elements, right? Fluorine. Fluorine is the element with highest electronegativity value. And chlorine is the element with highest electron affinity. And about the metallic nature, what happens to the metallic nature from top to bottom? So the metallic nature increases from top to bottom. Okay, and in a period from left to right, the non-metallic nature increases, right? So, and you just try to learn about the metallic properties. Okay, so what are the properties of metals? And you can just check out whether they are good conductors of heat and electricity or not. Then why they conduct electricity. So What is the theory which is involved with it? About all these things you can learn in this chemical bonding. Okay, and from this chemical bonding, another important question which you may get is hydrogen bond. See, what is hydrogen bond? We can say that hydrogen bond is nothing but arresting a proton in between two electronegative atoms, isn't it? H2O. H2O has intermolecular hydrogen bonding. Inter means what? In between. When the hydrogen bonding arises in between two molecules, it is called as intermolecular hydrogen bonding. Intramolecular. Intra means what? Within itself. If the hydrogen bonding is within the same molecule, it is called as intramolecular hydrogen bonding. Okay, so these are the very important questions what you have to learn from chemical bonding. Okay, so sir has again joined. Okay, so due to a few technical problems, he's facing some internet issues. I think everyone is online, children. Okay, so because every teacher is making lot of efforts to teach you children, even though we are not technically strong, so we have learned everything during this pandemic, right? And we are trying to reach you because of the like generosity by our AD sir, Sri Satyanarayan Reddy Garu, who has given the opportunity to meet you all during this pandemic, wherever you are, right? You will be watching this webinars, children. I hope you are all following us. So then coming to the next one, that is what you have to learn from this chapter is resonance. See, what is resonance? Writing two or more different structures for the same compound, which has the same molecular formula. But just 1 minute. Okay, children. So the phenomenon of writing two or more structures for a single compound, but none of the structures individually can explain its entire properties is called as resonance. See, benzene is a compound which has a molecular formula C6H6. We will write three structures for benzene. Okay, so but when you take only one structure, it can never explain the entire properties of benzene. That is called as resonance. Okay, just try to learn how to draw this resonance structures. And the most stable one among these resonating structures is the resonance hybrid. Okay, and then what you have learned, dipole moment, isn't it? What is dipole? Di means two, poles means the charged particles, isn't it? So dipole moment is defined as the product of distance between the two poles and the amount of charge present on any one of the poles is called as dipole moment. So please try to learn about the dipole moment also from your chemical bonding, children. Okay, so then and from this chapter I have told you what you have to learn. Okay, so please start sharing the screen, sir. Jahangir, sir.
Yes, madam.
Yes, sir.
So third type of intermolecular forces are known as dispersion forces or London forces. Usually these dispersion forces or London forces are existed in between in between the non-polar molecules are symmetrical electron distributed atoms. Let us see here one example. Helium atoms are in between the helium atoms, how the attractive forces are developed. So helium contains 2 electrons around the nucleus. So electrons are distributed symmetrically, means equally present around the nucleus. And the second helium atom also, electrons are cloud is distributed symmetrically. So in this type of symmetrical type of atoms also, attractive forces are developed, because in this symmetrical distribution of electrons, at one of the particular moment, due to the electron distorted takes place at any one of the particular moment. 99% electrons are distributed symmetrically only. At 1% of chances, electrons are becomes what, distorted. Due to the distortion of the electrons by the influence of the other atom, the electron clouds are becomes what, distorted, and it develops positive and negative charges. So due to the development of positive and negative charges in between the two atoms, the attractive forces are developed. These forces are known as dispersion forces, also called as random forces. So these forces okay.
Dear children, due to some technical difficulties, Sir has left the class, and today we have started the states of matter to you. Up to now, what Sir has told, so please go through that. And in our next session, without any technical interruptions and all, so we will try to see this class to be successful. And thank you everyone for giving us this wonderful opportunity and to be a part of this.